I saw one question while I was getting ice cream and tea. And the question that I saw was, how do you make a relative pointer that points to itself? And the answer is it just works, which I will just show and then I'll explain. So first let's start with not relative pointers, right? So I'm going to say P is a void pointer, right? And I'm going to say, I'm going to assign P to the address of itself. And I'm going to say print, well, first I'll print address of P is, right? So star here is the opposite of what it means in C. It means take the address of something. It means the same thing as it does in a type. This means the address of a void, right? And this means the address of a value. So, yeah. Anyway. And then I'm going to say P is whatever, right? And that's it. So let's compile that. So star P is whatever and P is whatever. So that's absolute pointers, right? Let's make it a pointer to a relative 16-bit, right? So it should be exactly the same. Oh. What happened? Oh, sorry, S16. I do that a lot. Okay, so you'll see the same thing happens. Boom, boom. Now, why is that? Well, let me do one more thing. I'll say print the bytes stored in P are, right? And then I've got this function print bytes in the standard library that takes a pointer and then how many bytes you want to print, right? So I'm going to print bytes P size of type of P, right? So now for the absolute pointer case, this is going to not be a surprise. So right, P is this thing in memory, and the bytes stored in P are, it's a little endian machine, so they're in reverse order, but F0, B2, C4, right, 0, 4. Same thing. When it's a relative pointer, it is not actually storing the offset directly. It's storing an encoding of the offset that allows you to represent 0, but not as the number 0, right? So it actually sets the high bit. So it's a 2-byte pointer with the high bit set and then zeros in the low bits, right? So basically, the encoding that we use currently for relative pointers is if the value is 0, then the decoded value is null or 0, right? Otherwise, we XOR by the high bit, right? Which allows us to represent everything in the wide range from positive to negative, except the integer with the high bit set and no other bit set, right? Which is the negative extreme most number. Now, this may not be the best encoding. It's just the one that I picked at first. And it may be slower to decompress than some other encoding. So this one is about 7 extra instructions. They're fast instructions. You might think like, oh, 7 instructions sounds like a lot, but it's way, way, way less than taking a cache miss, bucko. So there's that. But also, well, I don't know. It's not that important. Anyway, so Fabian suggested one that is probably about 4 extra instructions. And all of these are cheap instructions, by the way. Like, we're not talking about cosine or anything. We're talking about like add or XOR or whatever. So we may switch to that one later. The disadvantage of Fabian's is you can't, his is basically add 1 instead of XOR or subtract 1, something like that. So you can't actually point at the byte 1 byte after yourself, which would not enable us to do 8-byte pointers, or sorry, 8-bit pointers, right? 1-byte pointers. But 1 byte pointers may be so small that in practice you don't really want to use them, or if you do use them, maybe you're just aware that you can't point to 1 byte in the future, and that's fine. And we can, as part of the overflow checking, which we don't have yet, we can always just detect that situation if you ever do it. So that's the current situation there. Does that make sense? Okay. Let me look for instructions or questions. Relative pointer to relative pointer just works. Yeah, I mean, a relative pointer is just a number in memory, so you can take a pointer to that just fine. I mean, this is a relative pointer to anything, right? Check your second print. I don't think it's right. Oh, sorry. Yeah. Good point. I should have noticed that. Okay. So, right, this is just saying, so P is a relative pointer pointing to 0 bytes from its own offset, right, which is this address. Thanks for noting that. The result is approximately the same. It's just our print output's a little different. Someone's asking, could you give a relative pointer an unsigned number so it would only point forward in memory? Well, for now I didn't do that. I should have mentioned this in the main talk though, but relative to its own address is not the only kind of smaller pointer you might want to use. So for example, you might want a kind of a string that points into a known global string table, right? So maybe your program just has a bunch of strings and everybody in the program knows the base of that memory, and then your pointer only points into that memory. In a case like that, an unsigned value would make sense, and we may do that. It's just that I haven't added that facility to relative pointers yet of being able to specify that base. And in fact, we may, when we do that, the reason I haven't done that is because we may want to do something one step more sophisticated in general than that. So we'll see. But yeah, in that case, unsigned numbers would make sense, and you might want to do that to try to maximize how much you can reach. I simply didn't do it that way for now, just for simplicity. It was interesting enough just getting relative pointers like this working end to end through the compiler. Will the programming language provide facilities for performing endian conversion automatically? I don't think so, because I don't feel like that's super important. Maybe. I mean, maybe you could say this is a pointer at a certain endian and this is a number at a certain endian. But the problem with that is if you're going to do that somewhere in your program, I mean, you're maybe doing it everywhere. It just seems very messy. I suppose it depends on for what percentage of your data structure to use this kind of deserialization on. I don't know. I'm not convinced that it's that necessary or useful right now. You could, for example, so in the same way that we had this pack routine that iterates over a struct and looks at all the members and does things based on the members, you could have a version of this that looks at the numbers and swaps their endianness if it needs to be swapped, right? For example. If you did it exactly like this, it would be a little bit slow because you're at runtime looking at all the members. Maybe you don't care about that. Maybe if you want it to be faster, you could make a version of this that runs at compile time and outputs code to swap the endians, and that way it's maximally fast. So I'm not convinced that there needs to be language support for it because it's sort of a post-process step that you would do after loading the data. Like, I'm not sure why you want live data to be of the opposite endian. But maybe, if somebody can make a good case for why that should be that way, then I'm not necessarily opposed to it. Are there any cases where you can think of where serializing game data to human readable text is valuable? Yeah, I mean, our entity format is pretty readable. So, I mean, I've showed this before. So like every one of our entities gets saved in a format like this. This is not what that format would look like that we saw during the demo, right? This is like printing out the names of the fields and the values in human readable ways, and I can even edit the values and stuff. So when we're editing the game, I use stuff like this. But when we're shipping the game, we don't load this stuff, right? We load binary data. And the reason is because you want to start up quickly, and etc. And you don't want to fragment your memory, and there's all kinds of reasons. Oh, why did I need that full string helper function? Thank you. Okay, this is a little bit of a weird thing. So full size string. So all full size string does is it gives us a pointer to some type, which we're going to assume is a packed string with relative pointers. We don't type check it, but let's assume that. And we just say like, okay, well, actually we assert at runtime. We don't type check it at compile time. We assert that it's a string of some kind. And then we look at the type info for the string. If that type info doesn't have a relative pointer, we just say, oh, it's a regular string. Let's return it back. Otherwise, we sort of decode the relative pointer ourselves. The reason we do that, even though the language itself, like I showed, the programming language itself will handle casting from packed strings to big strings, right? So why did I have to do this? Well, it's because of the following. For loops have two modes, right? When I demoed them a long time ago. They're a mode where you iterate and take the pointer to everything, or a mode where you don't put the star and you just take everything by value. And that's what we want, is we want the string by value so we could pass it to uppercase in place, because uppercase in place just takes a string, right? So we want to cast from our relative pointer string to an absolute pointer, which happens automatically, like I said. The problem is that for loops, if you do things by value like this, right now the semantics is that it makes a local copy on the stack of the value. And like I said, if you're pulling something out of global data and it's got relative pointers and you want to store it on the stack, the pointers probably can't reach anymore, right? They can't reach from the stack to global data, so then you get garbage data, right? So I can avoid that by taking by pointer, but then still, if I make a string on the stack here that I'm going to pass to this thing, I can't do it with the implicit casting right now, right? So I have to like de-relativize it myself. Now the reason why I'm saying this is temporary and probably won't be this way in the final version is that actually when you do this in a for loop, probably it shouldn't make an entire local copy of the value on the stack, right? Probably it should give you the value as like a read-only by reference. Basically, it's the equivalent of a const reference in C++, because you don't really want to copy it, right? And if you're not copying it, by the way, that sounds weird, but it's actually the same. When you pass a struct, like even a string, to a procedure, that's actually the calling convention for arguments right now too. So it's basically saying the same calling convention for arguments you would use to visit things in the array. And then if you do that, then this problem would magically go away, because the thing is still located in global data, and then the thing you have on the stack is only a full-size string, and then we're converting between those, and that works just fine, right? The only thing you can't do is put the relative pointer on the stack. I guess I'm not sure why. Oh, right. So the other way to do it would have been this, right? But again, this says take this thing on the right-hand side and make a by value copy of it. So it's sort of the same problem. So that's kind of funny. It's the things that, this is always why you have to implement this stuff and try it out, because you never know what the issues are going to be. And that is a small issue that I hope will completely go away. Now, just because I fix it in for loops doesn't necessarily mean it might not pop up somewhere else. So we're going to see about that. But I would like it to be completely perfect and transparent, and you don't have to think about whether it's relative things that you're dealing with or not. Someone is bike shedding about semicolons. Someone's asking if this will be better for new programmers to learn game development. I think so, just because C++ is so gnarly. I mean, you could learn to program games in less serious languages like C# or, Python or Lua, right? Something like that. So if you're learning, you don't necessarily have to program at as low of a level as this language is built for. But if you're learning game engine programming, then yeah, I don't know. Someone says, will there be support for memory mapped file I/O in the standard libraries? Maybe. The thing is, I mean, for a game, you don't, like if you're doing something weird like memory mapping, you probably want to control the nuances of that yourself. Like so the C standard library is built on this whole idea that like you want to fopen and then stream the file in, which is weird. Like in most cases, no, you don't want to do that. Like in games, usually I'm happier if I just have the whole file. Especially if I'm doing asset processing or something. There's in rare cases where it's like, okay, let's pull in chunks of this file. But I don't think I would use memory mapping for that. So there are cases when you would want to use memory mapping, but I don't feel like they're super standardized. So I'm not sure why the standard library would do that necessarily. I mean, it's something that people can do. They would just do it themselves. Is there support for stack allocated VLA? What's a VLA? Does that mean like virtual local address, or I don't know what that means. Have I taken inspiration from Go or Rust? The topic of those languages and how this relates has been covered a number of times in different pieces in other videos, so I don't want to repeat it. Why does value pointer of a string point to void instead of a character? Actually, it points to unsigned 8. That was probably a typo when I said void. And why is a string not an alias for a char array? Because I feel like type checking in that case might be a good idea. Maybe it's not, who knows? VLA is variable length array. Okay. So the question was, stack allocated VLAs. Oh, you mean like alloc A or something? Not currently, but I have something that's probably better than that anyway that we're going to demo next time. How many are testing the compiler? It's largely just me. There's Joshua Hulsman, who's also working on it. And that's it. Very, very small team right now. We do not have GoTo currently. We probably will. I just haven't done it. Because I haven't needed to. But you probably do want it for some applications, especially when you're doing meta programming and code generation. You probably want the ability to GoTo. What percentage of features do I think are completed? Most of them. Like I was saying in the pre-stream, I think there's probably about 2 major features that need to get done. And then there's a slew of more minor stuff that's more like just completing what's been outlined and demoed. And then there's other small things like the GoTo thing, like implementing GoTo is probably important. I don't count that as a major feature, but it should be in. But we're kind of getting there. We're kind of converging on what the language is going to be. Someone said, what happened to owning pointers that I mentioned a few years ago? You know, that was one of those ideas where... So the first 2 talks that I gave were the initial ideas that I had about what I would want in a new language before I started doing it, right? Once I started actually implementing it, I just found through the process of making it ideas that I felt were better. So like, I don't think I very much mentioned compile time execution. I mean, I probably mentioned it in those first talks, but I didn't say the whole language was based around it or something. But I found it to be so important and amazing. You know, so things like that happen when you start doing things for real. So I sort of don't feel like owning pointers like that is a thing that I care about right now. I haven't needed it. I haven't felt a desire to do it. And so I've sort of solved some of the problems involved in that in different ways. Like, hey, if you're going to serialize out a lot of your data structures like this, or do some other things like I'm going to maybe talk about next time, then you don't need to think about deallocation as much or whatever. I don't know. Will the pack function be part of the standard library, somebody asks. I think there will be a better version of it that can serialize either to binary or to text, I think. I think that would be a very useful thing for people to have. And then, you know, someone's going to come along and do a JSON one or something like that, but it won't be me. Someone's asking, how difficult or time consuming will the platform specific phase be? It depends on how you define that. Platform specific code optimization can take as much work as you will put into it for the rest of your life. So it just depends on how we scope things and what we decide to do. Am I going to be putting any sort of limitations on GoTo? For example, maybe you can't jump into other functions or into scopes where things wouldn't be initialized. Jumping into other functions, I don't think we will support that because that is crazy. I mean, unless you mean long jump, like in C. If we do long jump, it'll be different from GoTo. Like, yeah. Into scopes where things wouldn't be initialized. I think if you use GoTo, you sign the warranty that you know what you're doing. I mean, maybe there can be a warning, especially if data flow analysis says it looks like you're using this variable and you skip the initializer. Then we probably issue a warning for that, but we won't prevent you. What's the current story for loading a closed source library written in this language? Well, we haven't written that story yet. I don't think we're going to worry about that in the very absolute initial release of the compiler, because I don't want people to wait for features like that. But my assumption is that there will be some kind of mildly precompiled representation that still allows us to do all this stuff like, polymorphism and whatever on the code and name remapping and stuff like that. But that's, obfuscated and with most identifiers removed and things like that. Enough that people feel relatively comfortable shipping their libraries in it and don't feel like they're going to be, easily decrypted into source code. The thing is, we don't want to ruin all the language features, many of which require some representation that's early in the stages of compilation, right? So we just have to figure that out. But one of my friends who runs a software company that sells closed source libraries seems to feel like, we've talked mildly about this, and he seems to feel like that would be enough for him. So. Can I briefly discuss relative pointer similarities to near and far pointers? Well, near and far pointers use like segment table and stuff, which is a weird global variable. I don't see them as the same thing. And the thing is, near and far pointers still use absolute addresses, so they don't give you this serialization power, right? And unless you, maybe somebody back in the day did some tweaky thing that let you do that, but no. Anything that stores an absolute address is not going to really be serializable, because your operating system is going to randomize your addresses every time you start in order to prevent people from hacking you, even though that doesn't actually help. So, yeah. Is there support to inlining assembly directly? There will be eventually. There isn't yet. Maybe that's the third major feature. How did I get the data into the separate program? Okay, so I demoed this way back if you want to go back and look. It maybe is even the first demo of this language on the YouTube channel, but basically, so here I said add the file, right? So this says, hey, this file is source code for the program. But then I just add the string. So I say add this string as though it was a file, right? And that data payload string is this string of bytes that we made. That's all that we did. It's not a particularly efficient way to add data to the program because it's being added as source code. At some point, we'll provide the ability to add just binary data directly. I've been meaning to do that for a while. Yeah. Will I still implement all the typical debug symbols that other languages provide? I think so. We want to support debuggers. I think that's important. Would I ever be interested in writing a fast Photoshop clone in this language? Not anytime soon. But I was going to write a Photoshop replacement with a friend of mine a long time ago, like 15 years ago or more. And we never got around to it. I've hinted at a language feature along the lines of compile time data transformation that's more powerful than SOA. Any more teasers on that? Not yet. I have to. it's one of the things where I have to actually implement it before I start talking about it, because it might just, like I said, you have to test your thing against reality, and the more crazy it is, the more you have to test against reality. And this one is relatively crazy, and so yeah, I will talk about it when I've done it. Oh yeah, Sean is here and is talking about the Photoshop thing. Actually, I don't think I did braid for several years after that. I went off and contracted for a while. Can I give you a hint about the craziness? No, I cannot. I cannot. How long do I think it will take to make back the time I spent on the language? You know, so first of all, I'm enjoying myself working on it, so I don't think I really need to make the time back. But also, I've been really productive. It just, you know, we've got to, like, if you watch that video, which is from about a month ago that I showed at the beginning, you know, we show a dude running around on a game level there, and that's like in a fully new engine that didn't exist a year ago, in a fully new language that still doesn't technically exist, right? So things are coming along, and you know, I have other things that help, like I'm pulling over stuff from the witness and translating it, and that helps us go faster. But I feel very, very productive in this language. So I think I calculated earlier that I've really only taken a hit of like 4 to 6 months, if that. So, by which I simply mean, you know, I started this thing a year ago, and if I had started making the game straight up in C++, it would have taken at least 6 months to put together as much stuff as I have now. I feel like. Maybe that's not true, but I feel like that's true. So if it's a year later and it would have taken 6 months, then we're at minus 6 months, which is not that long, frankly. Hidden bananas. I don't know. How much of the game's editor will I provide with the compiler? All of it. So we're going to give the game engine, like, we don't want to give the entire game because then other people will sell it. But we'll give like the whole engine and enough of the gameplay code that you could push blocks around and stuff, and all the editor and stuff. Yeah. Have I tried using Direct3D from here? No, but it would be about the same as using OpenGL, which I already do, so. Except it would be easier to debug, probably. Do I regularly exercise my programming skills and design skills daily? Do I feel rusty when stepping away for a while? Well, I've been programming daily for a long time now. I hadn't, yeah, so for the past year, I spent a lot of time not designing, and I felt a little bit rusty, but then I sat down and started doing levels for this new puzzle game, and they went pretty fast, and I was happy with it. So I think it comes back to you real fast. Do relative pointers mean you can do more with type info pointers, like deserialize arbitrary data structures consistently without needing to know types? I'm not sure I understand the question. I'm not picturing, like, you need to know what type something is to understand the data layout. So I'm not sure what you're getting at. If you could maybe rephrase the question or expound upon it in some way. So there's no C++ interface right now. There probably will be eventually. So right now we only call C procedures. So if we were to interface with DirectX, then yeah, we would use the C bindings. But that's what a lot of languages do. So I don't think that's atypical. But we do, for the purposes of interfacing with other people's game engine code, we're going to want to do like, understanding C++ name mangling and being able to call out to stuff or whatever. Do we use SDL? No. No, we use our own things. Part of the goal of writing this game engine is to give people the equivalent of something like SDL in our standard library on day one, so they don't have to like search around to find something usable. I won't prevent people from providing alternatives to what's in the standard library if they want to do something that they think is better. But we want to, out of the box, give you good code for drawing and playing sounds and stuff like that, so that you don't have to go on the internet and search for things. So if I were to use something like SDL, that would be counterproductive toward that goal. So that's why I'm doing it from scratch. Link to video of engine, or was that stream only? If so, no biggie. If someone wants to paste a link in the chat, that's fine. I was just referring to the Reboot Develop talk that I gave about a month ago in Croatia. It is not on my YouTube channel because YouTube doesn't let you link other people's videos on your channel. There we go, it's in the chat. I'll also put it in the YouTube text for this video. You are welcome, Dan Zaidan. Is it possible to bootstrap the compiler and use this as a scripting language? It will be. Right now we don't really export an interface to the compiler like as a library, but that's a design goal of like the final product, right? You're going to be able to just call out to the compiler and compile stuff. So yes, you would be able to use this as a scripting language or whatever. Do I think new programmers and game designers benefit from starting from scratch more than starting at a higher level? It depends on the individual person and their personality and where they are. I think from the very, very beginning, if you're just trying to learn it all, then I don't think you necessarily want to start from scratch because you don't have any context. And there's a lot of power to being able to make things happen quickly that it feels powerful and it feels neat. And also you just get a scope for what can the computer do and how can it do it. So you maybe want to use a higher level language when you're starting, right? I used BASIC when I started. And then that idea extends to maybe using libraries or a game engine or something, right? If it's somebody's first attempt to make a game do something, go ahead and use the Unreal Engine with blueprints or whatever. It's fine, right? I think it's just, as you're building skill as a programmer, you want to then understand how everything happens. Otherwise, you're limiting your own knowledge, which is not a good idea. So it's as you advance that I think it's important. You don't have to rebuild everything for yourself, but you should be able to rebuild everything, given an infinite amount of time or whatever. How large in megabytes is the compiler? Well, the compiler has no data, and the executable is right here. It's a 14 meg executable. I don't know why that is so big, honestly. I guess Visual Studio makes big binaries these days. I guess. Oh, and then also there's the modules folder. There's going to be some junk files in the modules folder. I don't know. This is an upper bound. So that's 5 point something megabytes. So it's 20 megabytes is like the upper bound of how big the compiler is right now. Yeah. Will the compiler standard lib be baked in the executable so you can copy one file around as the compiler? Well, maybe. That's an interesting idea. The problem is, well, you're going to want to update your standard library, the equivalent of your includes. And also you want multiple versions. Like when I distribute a program, I'm going to want to say, this is like uses version 1.2 of the print function, and that's been modified since then, right? Or whatnot. That's actually maybe that's the fourth major feature that needs to happen. There's so many things. That won't happen until after, like I'll do a test release of the compiler to a limited circle of people, and that won't be in there yet. But you're going to want to. So I think the idea that there's two ideas about the way that you provide compatibility, and I think one of them is poisonous and stifling. The one that's poisonous and stifling is, here's our standard library headers, and we're just going to keep updating these as time goes on, and our updates are going to be constrained to provide the same API to you forever or whatever, right? I think that's fine for bug fixes, but sometimes you need to fix real problems. Like sometimes the API is bad and you need to make it better or something. And I think then you just break it and you make a new revision and you let people compile to the old library, or you let them compile to the new one, right? And so we're going to do like that. And so you're going to want to be able to update is all I'm saying. So it won't be that baked into the executable. What did I know about compiler creation before starting this project? When I was in college, one of the reasons I dropped out of college was because I liked making programming languages more than doing the actual classes. So relative to most people, I had quite a bit of experience in toy languages. But I took some far enough that I wrote programs in them that worked, but I never took anything nearly this far, right? And most of them were interpreters and not compilers as well. This one, by the time I gave the first demo in, October 2014 or whenever that was, over 2 years ago, I already had that little Galaga game that was a whole game rendering in OpenGL, which by itself was probably further than I'd taken any of my other toy projects. Someone's asking, why do I use Windows 10? Because Linux is more painful. Is there any language feature that would help with optimizing binary size? I think having a good picture of what is taking up size in your binary helps. And we've shown features related to that before. So like the Go Bananas demo showed, the sizes of various functions and stuff. So I think if you have that kind of facility and you can tell what's taking up space code-wise easily, then that's good. How is progress going with regard to thinking about a binary module format? I already answered that question 10 minutes ago. How much work went into compressing the witness? It was not trivial. It's not trivial. Although, at the same time, we also didn't work forever on it. Like, we're actually compressing the data more now that we have to release on mobile platforms that'll kill us if we use more than 500 megabytes of RAM. So, like with any optimization thing like that, you can put an infinite amount of work in. So we're just putting more in now. Have I ever had problems with my arms or wrists? A little bit, like by typing, but usually that's due to problems in, the relative level of the keyboard or the angle at which I type. So I use a laptop a lot, and I'm very picky about laptops. I don't buy laptops with off-center trackpads and keyboards. Like laptops with number pads on the side are a bad idea because you kind of are scrunched over to the side. It doesn't seem like much, but I think that leads to problems. Of course, basically all laptop keyboards these days are garbage, and that's bad for your hands too, so whatever. Do I think compute shaders would benefit image editors, or just doing normal software rendering would be sufficient? Well, I think first you have to get your image editor working, and that should just use software. And then once it's totally working and doing what you want, then if you want to make it faster, you could try using compute shaders. And then hopefully architecturally, you thought about this plan and you made it not totally ridiculous to try to introduce compute shaders into the architecture. Any plans for a package manager like Cargo for Rust? I don't know. I mean, I want it to be very easy to get new stuff, but at the same time, I really I've never used Cargo or anything like that, but the fact that so many Hacker News people think it's great makes me presume it's terrible. That's my own personal bias, but I mean, all these people use Git and think Git is amazing, and I'm just like, I don't know what you people are smoking, right? So, yeah, I don't know, man. So I don't know much about how those package managers work. I would like it to be easy to pull stuff down, but I don't want a rat hole around the package manager, right? So I've used CPAN with Perl sometimes, and that's a little bit good, but not as good as it should be. I should be able to say, pull down all the dependencies that this program wants. And that should just happen, and I shouldn't have to think about it. But yeah, I haven't thought about it more than that. Why is it so bright in SF? This is not San Francisco, this is Seattle. How many lines of code is the compiler? 37,491 when you strip out comments and new lines, which is 0.3% the size of GCC or something. I don't know. Yeah, pull all dependencies, I think, is important. And then we'll see. We'll see if we need, once you have that, you also have just pull down a package called this, or query for who implements this function, right? And once you've got those couple of things, I kind of feel like that's most of what you need. Maybe I'm wrong, but like I said, I haven't used Cargo or any of these web people's things, so I don't know what they do. Did I say there was another feature I'm going to demo soon? The next demo is going to be probably Friday, and it's going to be just a collection of smaller things that have been implemented. Like, I consider relative pointers a big feature because it like touches the core of the language, or it's like end to end through the language. And this other stuff is going to be smaller features, but that have pooled up and like, hey, I might as well do a demo and just show them all. Do I plan on doing a public beta test soon? Not too soon. I feel like that's the end of the questions. Are there any other on-topic questions before I go watch the... Did the AlphaGo match start?
Interesting that there's this...
Oh, they're in the middle of the game. So let's finish any possible final questions so I can watch this. I think I'm not allowed to watch this on stream. I think Twitch will ban me again if I do that. When I finish a feature like relative pointers, do I go back and rewrite Sokoban's code? Not yet. This one is, I more implemented it because I wanted, basically I'm loading meshes as ASCII right now in Sokoban, and that's a little bit slow, and it gets slower the more meshes you start putting in the game, and we're putting more stuff in the game. So startup time is getting slower, so adding mesh processing would be good. And to do that, I could have copied the mesh processing that we do in the witness, which is much more manual than that. And has some post-load steps to it and stuff. And I was like, you know what, let me just, if the whole point of this language is to do a better job, let me try and do a better job on this thing. So that's what I'm in the middle of right now, and then we're going to see how it goes. I've said I want to make an OS in the future. What do I want in it besides stability and privacy? Simplicity. So there are two things that Linux needs to be better, right? One is it needs to actually work on everybody's computer. And two is it needs to be a lot more simple than it is, because it's got all these Unix holdovers that are not necessary and that make everything complicated. So those would be the two things I'd change. All right, any on-topic questions? Any questions about what was demoed today? Yeah. The link to the AlphaGo game you can see at the top here. It's just search for Future of Go Summit in Wuzhen, China. All right, no more on-topic questions. Thanks everybody for coming by. I'll post the whole thing to YouTube later if you missed it. See you guys later. Bye-bye.